Okay, so the phases of the moon. We talked about how a cycle is 29.5 days, so we call it a month. In a month, we have our different phases of the moon. The actual time is 28 days around the Earth, but the way we see it is in 30 days. So moon phases reflect the change of the appearance of the moon seen from Earth. So this depends on where it is in location to the Earth, Sun, and the moon. That means I have a little optional activity for you to do if you would like to do it, so that way it's easier for you to use and you can actually use it on your test. So the lunar phase cycle goes through each one. So on our new moon, which is day 29, we create, and day 0, we create a waxing effect. Waxing means that we are moving from a new moon to a full moon. Waning means that we are waning off. So wax on, wane off. So when the side is facing, the moon is facing away from the Earth, it is lit by the sun. When the side is facing the Earth that it receives sunlight, you create that full moon effect. So like I said, waxing is when something is illuminated. It is leaning towards your full moon. So if you started out, this is your first quarter. So your first quarter is when it is on, when you're looking over the sky, when it is on your right side. Yeah, that's correct. So right side is going to show the waxing phases. So we have 3 different things that we call it. We call them the waxing crescent, meaning that you have a smaller lit up area. Your first quarter, which is when about half of it is shown, and then your gibbous when it's more than half. Your waning phases, of course, are moving away, so they're going to be towards your left side. So crescent, gibbous, and quarters are the same, except they're called waning. And your third quarter, so which is your quarter before the full moon, before the new moon, after the full moon, that is going to be what your waning quarter is. So the word for month is derived from the root of moon. That's why most months are 30 days. So an eclipse, a solar eclipse, is when the moon moves directly in front of the sun, creating a shadow on the Earth. We had one of these in 2017, and we're actually having another one in 2024. So we'll be lucky enough to see 2 in our lifetime at one of the best areas to have it. The solar eclipse is the shadow on the Earth from the moon. So the darkest portion of the moon's shadow is called the umbra. So the umbra is the very tiny portion that is put onto the Earth's surface. So there is the path of your moon. The umbra is what happens when you see the moon cross in front of the sun. So you can start seeing the moon at about 60 minutes before totality, and then totality, you see that bright light around the moon. It's pretty cool. If you didn't get to see it in 2017, I hope you get to see the next one in 4 years. Lunar eclipses are when the Earth comes into between the moon and the sun. So this means that the moon is being covered up by the Earth's umbra. And it's pretty cool looking as well. So it looks like it's going to completely disappear, and then it turns red almost. So, and that is your lunar eclipse. Pretty cool. So the moon is made up of basically the same material that the Earth is. The only difference is that it does not have an atmosphere to protect it from asteroids. This creates Maria and craters and mountains that are visible from the Earth's surface. So the depressions are called craters, but they usually create these Maria mountains. So Maria Mount is Latin for mountains. These are the dark-colored lava-filled flat regions on the Earth. So it looks like mountains from the Earth's surface, but it is actually this flat land. So they surround large depressions that are later filled with lava from when they were thrust upwards from the original collision. and the impacts on the moon throughout history have led to a larger collection of this dust, because when something is slamming into the surface with nothing to stop it, it creates dust particles that are shot up and then later settle on the earth, or on the moon's surface, called regolith. So the moon's interior has a dense, solid, magnesium-rich core. Uh, it is not moving, unlike the Earth's core is. It is solid. There is no more heat being given off. So the theory is that there was this giant impact of a moon-sized or a Mars-sized object with Earth, and it slammed into Earth as it was cooling and forming. So when this happened, the colliding cores combined and then settled towards the center of the larger object, being the Earth. So that meant that it was pushed off and thrown into orbit and created into this dense mass that we now have as the moon. So that is another proof of how the Earth is based on that theory. That is another theory we can use to see that the Earth is round, because all of this debris was thrown from the collision and condensed back into a sphere of the moon. So remember, if it's thrown into orbit, it'll gradually come together and forms into that moon mass. That is the instance that we're giving. And we don't know 100% sure if that is true or not, but that is the theory that we have based on what we see from other moons in our solar system. All right, that's it. Good luck on your test when you take it. I don't know when it will be, but good luck.